All right, so hi everyone, welcome to my YouTube channel, City of Elections, and in this video we're going to talk about this, the Z transform. Now, what you have to bear in mind is that this guy is a tool. This is the first thing you should have in your head. It is a tool. Okay, Z transform is a tool, but what kind of tool? Mathematical what? Tool. Okay, it's a mathematical tool. And what is it used for? Dealing with discrete time control system. Now, this is the other thing you have to bear in mind, discrete time. Okay, so what do we mean by discrete time? Control system, of course, automation, things happening without you physically handling them. It's either you've programmed it to behave in a certain way, or you've set it, same programming, you set it to or you control it remotely. Okay, control it without touching it. Okay, so that kind of idea. But that thing, that system, that control system, now it's on discrete time. What do we mean by discrete time? What do we mean by? Okay, now for this mathematical tool, let me just quickly explain what this mathematical tool means. Okay, before we go to the and what discrete time means, and then understand what Z transform is all about. So let's do this. Let's do it right here. Now, now, in real life, when you want to fix maybe something, you want to unscrew something, you need a screwdriver. Okay, you need a screwdriver or spanner and things like that. Those are physical tools. Now, if you want to solve equations, okay, if you want to solve equations, okay, equations. Now, equations or series or math, all these things are what? Mathematical representation. Let me say mathematical representation of real life system. So equations, series, and all them being mathematical representation of real life system. Mathematical representation of real life system. Now, if you want to solve that mathematical representation of a real life system, if the real life system is x, okay, let me not say x for now, that's too fast. If the real life system is continuous in time, if the real life system is continuous in time, meaning that this is time, 1 second, 2 seconds, 3 seconds, 4 seconds. Okay, this is time. Now, and this is this is whatever, let's say x of t, because x will be a certain value depending on what t, when t is 1, when t is 2, when t is 3. But now, something like saying temperature, real life things that exist, they are continuous in time. So it's not just 1 second, 2 seconds, it's one. We also have, like, it is continuous. It is not broken. 1 second, you have something here, 2 seconds, it is continuous. It is not broken. Okay, for the one that is broken, at this point in time, at different point in time, you have something. So you see, for this one, you see they are separate, right? There's a value here, there's one value here, there's one value here. But for continuous, everything is linked. Are we seeing it? So the mathematical tool to analyze things that are continuous in time is what? Laplace transform. Laplace transform. And because they are linked, we want to take the sum of all of them, but they are all linked too. So we use what? Integral. That's why you see Laplace transform is together with integration. But when they are separate, that is digital, that's discrete. Oh, this one, continuous, is what? Analog. Separate, discrete, digital. So it's either there or it's not there. Now it's there, it's not there. Now it's there, or it's not there. Now it's there. Do you understand? But for this one, it's always there, but either high or not too high or low, but it's always there. This is continuous time. This one is discrete time. So for discrete time, to analyze this system, the mathematical tool used for it, first of all, you see we have something here, we don't have anything here, we now have something here. Because they are separate, we will not take the sum of them, sum all of them. So we use what? Summation sign. For this one, we are taking all of them together to analyze them, but what? In taking all of them together, since they are joined, we use what? Integration. And Laplace transform is the tool used. This one, discrete signal, they are separate. So you now take all of them. Since they are separate, you use what? Summation. And what is used is what? Z transform. Z transform. Exactly. So this is a mathematical tool used to analyze discrete time system. Okay. Now, okay, when we analyze it, what are we going to see when we solve the mathematical representation of the discrete time system? When we solve it, what are we going to see? Don't worry about that in this video, okay? Let's focus on handling how to find the Z transform of discrete time system, okay? That's what we focus on here for now. Once you get that, then maybe some other videos or some other classes or some other lectures or some other courses, we can now talk about how to analyze or how to identify properties in the mathematical equations that reflects the real life system. Hope that's clear. All right, so now back to this now. Okay, let me just hit on this completely. Now, since we said that this summation is what is used for discrete time system, and of course this summation, we are not talking about Z transform, we are talking about Z transform. For this discrete time system, instead of using t here, what we use is what? N is what we use. So here will no longer be x of t, but it will be x of what now? Guys, think it will be x of what? X of n. Okay? Some textbook make use of k instead. So here will now be x of k. All right? But let's just go with x of n because that's what we have in our book now, in our material. Okay, so let me write this thing. Let me rewrite this thing on that side to be clean and clear. So I'll clean that out. Now we said we are using summation, right? Now we will now consider what is n. Look at this thing now. What is, so n is 1, n is 2, n is 3, n is 4 to infinity. To what? Infinity. Okay, then also minus 1, minus 2 to negative what? Infinity. So we are adding all the values of what? All values of x of n. We'll add all of them from when n is what? Negative infinity to what? Infinity. So this guy will go from where? Negative infinity to what? Infinity. So we are summing values for what? X of n is also x of n. Okay, now one more thing to add. This, each value here, x of n when n is 1, then x of n when n is 2, like that. The time when n is 1 and that time it takes for n to get to 2, that period there is a delay, is that also? Then that period when n is 1 for it to get to when n is 3, that period there's also a delay. So to account for the delay, to consider the delay, there is something used. Z is what is used. Are we following? So for just a single delay, we say 1 over z, and 1 over z is what? Not be so. No, so 1 over z, this is the meaning. Now if we have two delays, how do we write this? Take this guy out. Let me use other color. If we have two delays, what? 1 over z times z. Two delays now, and that will be what? 1 over z squared, which is what? Z minus raised by minus 2. So the number of n will now give us the number of what? Delay. So if you have 1 raised by this, so now have what? 0 raised by minus n. So the delay of each term on the next term, the delay on each term. So that means our complete formula for Z transform will be what? This is power n. This is our complete formula for Z transform. That is, let's move this guy this way. That is, let me shift this guy, shift. All right, that pack everything. All right, that is what's going on. Okay, now that is if we say you have x of n being something, x of n equal to something, x of n equal to something. Now to find the z transform of what x of n is, all you have to do is just to say, let me put this. To find the z transform, all you have to say is what? X of z equal to, this place is too tight. Just hold on, guys. Okay, so all you have to do is just to say x of z equal to all this. So whatever x of n is, you just plug that value here inside the z transform formula and say the z transform of x of n, which is now x of z, equals all this. All together. Let's try an example and see how it goes. So let's just go back to that material and see. So this is the formula. Yeah, perfect. This is the formula. Don't worry about this thing. And this thing just says x of z. It means z function. Okay, z function. This is just the meaning. So let's go. Oh, I forgot to mention this. Let's see how fast we can say that. Now, since the z trans. Okay, did I mention? Okay, now the z transform is a mathematical tool. I've shown and we've seen the formula and it's used to adapt. Now, in the case of discrete time system, continuous time, which is t, is usually replaced by discrete time, which is n, just like I said. And the z transform of the same, the z transform of the same described as what? This. Now, since the z transform is an infinite power series, okay, because these guys are going from what? Negative infinity to positive infinity. But what? This guy is what? Z raised to power minus n. N now is going from what? Negative infinity to positive infinity. So what? The z transform is an infinite power series and it exists for those values of z for which the series converges. Now, the region of convergence is termed as ROC. R region of, that's O, and C convergence. Now, it is the set of all values of z for which x of z attains infinite value. Bear in mind that if z is 0, look at this guy here. Where are you? Come on, guy. Okay, if z is 0 raised to power this and now divide this, it doesn't make sense. Okay, the region of convergence is termed ROC and it is the set of all value of z for which x of z attains a finite what value. Now, the region of convergence, I'll talk about this, okay? For this line here, the region of convergence will be on entire values of z plane except z equals what? 0. When z is equal to 0, we are not, it's no longer converging again, okay? Once z is equal to 0, we are not going to get a definite value for x of z. Okay, now what's happening here is just that the first term, second term, third term, fourth term are like that. When n is 0, x of n is 1. When n is 2, sorry, when n is 0, okay, x of n is 1. Let me just put it on top of it so it will be easy for us to identify. So here n is 0, n is 1, second term, sorry, 5. Okay, so this is for n. All right, now when n is 0, x of n is 1. When n is 1, x of n is 2. When n is 2, x of n is 5, and so on and so forth. Then the z transform will be what? Where is that formula? Let's see if we can quickly work this out. So we said the formula is what? X of z. So if you go closer. Okay, so x of z is equal to what? Summation n equals this and then to this. Then you now have x of n. We now have x of n, and then z raised to the power what? Minus n. So x of n is this. Now we are told that, so in the first case now, for the first case now, considering this, the first case now, so we just substitute there these values inside. So what we're going to get for this one, and x of n, they said is what? 1. So here will be what? So we'll have 1 here, times what? Z raised to the power minus n is what? N is what? 0 power minus 0, and of course that is what? 1 raised to the power 0, and anything raised to the power 0 is what? 1. So we have 1 times 1 equals to 1. So we have 1 there. Okay, and then so that's how we have x of z. For this first term, x of z is what? 1. Exactly 1. Okay, so let's do for the second one. When n is what? 1, x of n is what? 2. So let's replace that. Let's replace that. So okay, now x of n is what? Let me mark it. We are in the second place, so this is where we are now. So x of n is what? 2. So here will be 2. Okay, so let's put it here, 2 times z raised to the power what? N is what? 1. So let's put it there, raised to the power minus 1. So this will give us what? 2z raised to the power what? Minus 1. Exactly what we have here. Are we following? Then let's go to the third one. So at this point now, let me wipe this guy out. So at this point now, let's take this one out. So at this point now, x of n is 5, which is here will be 5. Put that there, 5. Then times z minus n is what? 2. So you put that there. 2. So the 5z raised to the power what? Minus 2. Exactly what you have here. Are we following? So let's just complete it. Then the next one now, this. So x of n will be what? 7. So here will be 7. Put that down, 7 times z raised to the power what? What do you have here? 3. When n is 3. So put that there. 3. So you get what? So you get what? 7z raised to the power minus 3. Okay, and then the next one, which is what we have here. Beautiful. So take this guy out. So now the next one is this. Okay, so x of n is what? 0 now, meaning here will be 0. That's for this part here, 0. Then times what? Times z raised to the power what? What do you have here? N is what? 4. So here will be 4. Now, 1 0 multiply anything, that guy is gone. So everything will be 0. So there should be nothing here. That means that x 0 raised to the power 4, we don't have it here. Okay, that is missing. Then the next one now, let's go to the next one. Which is this one now. So x of n will be what? 1. X of n will be 1. So here will be 1 times z raised to the power what? N is what? 5. So here will be what? 5. So what do we have is what? 0 raised to the power minus 5. So here should be 0 raised to the power minus what? 5. Put it there, minus 5. That should be what? 0 raised to the power minus 5. And listen, I have browsed, I have checked about this thing. All I got is that this place is actually, here should be actually minus 5. Okay, you can browse and let me know in the comment section if that's okay. But I have browsed and I've seen that here should be minus 5. 0 raised to the power minus 5. Okay, maybe that was due to typographical error or something like that. All right, so that's about this part. Okay, so that's how they got all this. Now the region of convergence will be the entire values of z. Oh, I've explained this. entire values of z plane except at z equals 0. Okay, so that's that. Then example. Now the example is actually easy. It's almost like what we just did. Okay, but yes, it's an expansion. What we just did is actually simple, saying that x of n is this, s of n is very simple, straightforward, simple whole numbers. But in this case now, x of n is what? Now a number raised to power n multiplied by unit step function. Multiplied by what? Unit step function. Now I will explain what unit step function means. This u of n, we say u of n is the unit step input. I will explain what this u of n mean and end this video here. The next video will now solve this example. Okay, so let's go. U of n. Now from from the name, so from the name, unit step, unit and step, guys, bear this in mind, look at this thing. Okay, look at this. Of course, -1, -2, what are you doing? -2, -3, and so on. Okay, then 1, 2, 3, here will be 0. Okay, 4 and so on. Then here will be -1, -2, then 1, 2, 3, and so on. Now x of n, and then what? N. Now unit step function just mean that when you look at all these values of n, unit step, it means at this point, we now move what? 1 unit. Sorry about the heart. Oh, guy. We now move what? 1 unit up. All right. We now move 1 unit up. That is where 1 is. That's a unit. Okay. When we move that unit up, what do? We keep that step. We keep that what? Step. So n, are you saying that all the values of n, when n is greater than 0, then we have what? X of n will have values. Exactly. When n is greater than 0, then we have values for x of n, you see. Okay, but when n is less than 0, we do not have values for x of n. When n is greater than or equal to 0, look at it. When n is 0, we have x of n. When n is 1, we have x of n. So as long as n is greater than or equal to 0, we have what? X of n existing. Okay, so we'll use this idea in the next video. So like, share, subscribe, comment, and I'll see you in the next one. Bye for now.